Hello, in this video we are going to see one objective type question. This is the question. This is from exemplar. This is from exemplar 14.4. A 220 volt AC supply is connected between points A and B. Figure 14.3 figure is given here. What will be the potential difference V across the capacitor? This is input here, this is a capacitor. You are given option A 220 volt, option B 110 volt, option C 0 volt, option D 220 into root 2 volt. I will give the answer first, then we will see the explanation. This being MCQ, the answer would be option D. This would be the answer. We would see why it is 220 into root 2. See, this circuit diagram is that of half wave rectifier. Because only one diode is there here, it is a half wave rectifier, and the output okay, the diagram would be very rough because it's a hand drawn diagram. So this is one time period. Okay, this is one time period of the time period of the input wave. So first half there is output, second half of the input cycle there is no output. Okay, it goes like this. This is the waveform, output waveform. Now how to explain the output here? There may be a load resistance connected here between the terminals I have shown. See, from this point to this point, this is the output without the capacitor. So this is without. This is without the capacitor. Okay, that means it is not filtered by the capacitor. Now there is a capacitor. How the output form gets modified we are going to see. See, from here to here the input voltage increases. This 220 volt, let's say. Obviously from say O to A input voltage increases. That means the diode is forward biased. The diode becomes forward biased. And also you assume this diode to be ideal. Ideal diode means forward biased. When an ideal diode is forward biased, it acts as a short circuit. Therefore the circuit diagram would be like this. Capacitor. Of course there will be a load here. This is short only when it is forward biased. The diode is forward biased. And here you have input 220 volt AC as is given in the question. This is VI. This is a diode equivalent circuit as if it is shorted here because it is forward biased. Now we can see whatever is the input voltage variation, that will be followed by the capacitor. Whatever is the voltage here would be followed by the capacitor. So this is the input side. As it increases, voltage across the capacitor also increases, and the capacitor gets charged to the maximum value because capacitor is getting charged. So this is the peak value Vp, because whatever happens to the input side here, whatever happens to this Vi, that will be followed by capacitor, because this is the equivalent circuit. once this point A is reached here, the capacitor is fully charged because it is a maximum voltage. The capacitor is fully charged, right? Then you see after this, see this will be input if you want. After this is voltage and time. In this case the voltage decreases after reaching the maximum extent. But this side, N side has the capacitor voltage. This N side has the capacitor voltage. Therefore, diode becomes reverse biased. Therefore, equivalent circuit is an open circuit. Therefore, there is no output from the diode. So the capacitor discharges from this point onwards because the diode becomes reverse biased. Why? Because the voltage across the input voltage decreases. So capacitor discharges. When the capacitor discharges, the voltage across the load increases because of the discharge. So the capacitor discharges, giving voltage, say up to this point. Again, the next cycle, the capacitor will charge to the maximum extent. So this is Vp. Then from this point onwards, the diode becomes reverse biased, so capacitor discharges. So when there is a capacitor, the output can be drawn as, I will draw the diagram here. Roughly like this. Okay, this will be the peak value of the voltage. So for most of the time, voltage across the capacitor will be near the peak value. The voltage across the capacitor never decreases. Moreover, the capacitor discharges very slowly here. Therefore, here the voltage is near the peak voltage. So RMS is given 220. So peak value of the voltage will be 220 root 2. So correct answer is 220 into root 2 volt. Have you understood this? The diagrams are very rough, so just follow the concept alone. Okay, this is when reverse biased. So the answer is option D. Thank you.